Hello and welcome to This Month in Security. I'm your host, Aubrey King. And joining me this month, we've got Aaron Brailsford.
Maybe they'll pivot to, well, we don't have to break the application code, we have to break the compiler optimization.
Amina Mubin.
Here is me. I just went in and unplugged it in. The screen came on, the prompt came on, and that was it. I turned it off.
Malcolm Heath.
So there are definitely ways you could configure a MacBook or any other device to be a highly isolated environment when it came to RDPing into your network. And clearly that would be the way to go.
And Sander Vinberg.
The DWrite engine in Windows now has more lines of Rust. It has 152,000 lines of Rust and 96,000 lines of C++. So it's moving.
So strap on those earbuds and get ready for This Month in Security.
So this month, we've got a whole bunch of things to show you. We've got a conversation with an F5 support engineer who specializes in security incident response. In addition, I'll be sharing the first in a return to Real Attack Stories, a Dev Central feature, where I'll be showing you, if you don't already know, what DNS, water torture, or resource exhaustion more appropriately is. And we've got an interesting treat. The news is going to be taken care of by Aaron, Sander, and Malcolm because I was sick from the fires up in Canada. Now, let's kick things off with a day in the life of an F5 security support engineer.
Today, I'm joined by Aaron Brailsford and Amina Mubin, both from the security incident response team. How are you guys doing today?
Good. Thank you, Aubrey.
Yeah, me too. Fantastic.
Great. Well, you guys are a little further ahead of me time-wise, of course. I'm still tired because it's morning and I have a hard time waking up, but you guys have been at it for hours and hours. So if any editing's got to be done, it's going to be on me, I'm sure. So we are going to talk a little bit with Amina. Let's talk to the community and just let them know what it is that you do for a day-to-day, because I think it's fascinating.
I work in the global support team, and I'm a support engineer. I support big IP support products. So my day-to-day is me getting a case, going through the case details, working out what the issue is. If I need to get additional details, obviously I call the customer. And then based on that, I do my investigation. We also get packet captures and logs, going through logs, doing our analysis, figuring out what happened, where we can help them. And other than that, I'm also a member of the CERT team. So I get to work on security incidents where it can be a vulnerability, customer wanting us to advise them if a vulnerability is affecting them, if they should upgrade, what are the mitigations, stuff like that. They can also invoke ESRP, which is a process where it's an emergency and then, for an ongoing attack. And there are oftentimes customer report that there is an imminent attack, and we help them check traffic patterns, logs to figure out what may lead to an attack. Also check their configurations, help them raise their defenses. And that's day to day in a support engineer / security incident responders day.
It sounds like you work on like all the fun acronyms that F5 has to offer. Those are some serious software packages. I mean, so, with ASM, if you're a community member out there and you're familiar with LTM and GTM and haven't, scratched the surface of ASM, you got to be prepared to know the guts of HTTP and kind of exactly what you're looking for an application attack. So it sounds like you would have to have quite a bit of required learning to kind of understand some of these things. Can you help explain, I guess, how you got where you are today? What kind of education or training you might have had to go through to gain some of these skills?
Yeah, well, I partly blame my dad. And this is from my childhood and my curiosity. It goes back when I was 8, maybe. And he got a personal computer, old looking computer with a printer, dot matrix.
Does it look older than Aaron's computer in the background?
Yeah, it was older than that. It had that big floppy disk and a power on button in the back. And so the funny thing is that he never turned it on himself. And I was getting curious. It's like, what is this machine? What is this? Because at that same time, I had seen Terminator and Skynet was all over, like machine. Wow. But yeah, one time he went out and curious me, I just went in and unplugged it in. The screen came on, the prompt came on, and that was it. I turned it off because it's like, this is, whoa. So then my dad came back home. And then he called me, he took the manuals and he just gave it to me. And he said, I knew you'd be the one to turn it on. So, yeah, so I learned DOS. Then we had computer classes in school. So I learned a lot about computing that way. And this is going back 1990s, 92, around that time. But I did lose an interest when Windows 95 came out, or probably, it was Windows 95. And I was playing video games and lots of sports. So yeah, the computing was out. As in me sitting on a computer and breaking stuff. I was breaking other things like the Discman or Walkman. But yeah, repairing my dad's radio. But yeah, I did go to uni. I'd studied electrical engineering in telecoms. That's again part my dad's to blame. I wanted to do arts. What's wrong with you?
It's
Wake
an art.
up.
It's an art.
But yeah, pardon?
That is an art.
It is an art. I'm so creative, because I wanted to do illustration, and that's also using computers. But he said, no, do what I did, because he's also an engineer, but a different field. But the worst part is I graduated, but I actually didn't get a tech role. I found jobs in sales support. I became a technical account manager, and these are all in IT companies, telecom service providers. And I tried very hard to, hang out with the engineers, trying to figure out what do I do. I did CCNA, Red Hat, but I still couldn't get a job. And there are two reasons. I think it was I grew up in UAE, and the minimum amount of experience they look for is 5, or I think it was 10 actually. And there's not an infrastructure for women to work in remote areas. So, it just happened. Back then it was the scene. It's not so much anymore right now. They have made accommodations for women who work in telecoms, networking, and whatnot. So, but the thing is, then I saw a poster of a woman, and she was wearing a helmet, a tools belt, and she was up on a mobile mast, and this is somewhere in UK, I don't know, but and that's what I thought. Oh, that's what they do. That's what telco engineers do. They climb up mobile masts, and then use a screwdriver, get electrocuted. I don't know what, but it's like, I want to do that. But the thing is, it was momentous for me. This I packed my bag and I came to UK, and but I didn't get a job, and I didn't get on I didn't get on a mobile mast either. I studied further in communication, network, and planning, and I was introduced to network security, encryption, access control, and whatnot. But again, I still didn't get a job. I don't know what was wrong. But I worked as a sales engineer, and then I think a few years after, I did get a service desk job. And I think that was my foot into a technical role. And following that, years later, I came to F5. And since then, I've been happy. But the thing is, during this whole course, I did certifications and training, everything that would help me get into a technical role. But it's just I never landed an opportunity soon enough. So for people who are looking to get into cybersecurity, I think there are plenty of courses these days. I think CompTIA offers Security Plus. I mean, knowing Linux, Windows, Mac operating systems are quite essential these days, because the other day I was reading about PowerShell. You preventing a lot of attacks using PowerShells, and threat hunting using it, log analysis, and there's a whole thing about it on someone's doing a podcast about it. So
I learned a neat new thing about PowerShell while I was at RSA last week. I was at one of the keynotes with Kevin Mandia. I don't know if you know Kevin Mandia. He's a pretty big security name, but he was saying, yeah, he's with Mandiant. So he was saying that phase 2 on almost every single hack that they handle is PowerShell access. So almost every single one. So I mean, that says a lot to me about vulnerabilities. Although I shouldn't make any comments about any company, so I will not do that. And I guess importantly, I mean, it sounds like you've been through quite a bit to get where you are today. So I guess, in the spirit of was it worth it, I'd love it if you'd take us through like maybe what you're working on today and maybe like the worst of what you've seen insofar as hacks is concerned. Obviously not with customer names and things like that, but maybe kind of what's the worst thing you've had to handle there, and give us an idea of kind of what's going on this week too.
This week, I don't think I had a piece of cake this week, but yeah, in the past few months, I really like DDoS attacks for some reason. There are plenty we see. We see. I'm not the only one. There are 2 other certain specialists. We take cases amongst us, but I didn't have this week. But I've seen another DDoS attack that happened. My colleague handled it. But yeah, we see a lot of volumetric attacks, SYN, MyCMP, UDP, etc. But my favorite is DNS. So this is the one that I am obsessed with. And in the last few months, I've been just reading about the history, the attacks that have been that have happened, the impact it caused, whatnot. So yeah, sort of, I mean, threat hunting is, you're like actively looking for ongoing attacks. I'm just sort of behind, but I'm still kind of doing it, trying to understand the adversary's mind and what happens. Anyway, so yeah.
Go crazy trying to figure that out. They're nuts.
Yeah, so I mean, DNS, it's just like it's relied upon by so many other services, mails, websites, of course, databases, and it is actually used in high percentage of cyber attacks. It's like, yeah, I want to be there. I want to know more and more. But yeah, and I also read that about 85% of new domains that are registered, they're all related to malware somehow or some other form of nasty business. But yeah, the one attack that really got me going was the NX domain flood attack. It was the water torture, where excessive amount of requests are for pseudo random subdomains are made by a botnet, fake requests. But yeah, this was what got me really interested in this. And as we know that when this is happening, it can take up all the resources, lead to slowness and an outage. So this is what happened to one of my customers that I was, the ESRP case I got, I think this was back December. And initially it actually looked like just a query request for A records. And the customer had AFM DOS protection, but even after we had tuned their thresholds, we were still seeing a whole lot of traffic coming in flood. So I had to do a packet capture, then extracted the host to see what was actually being requested for. And then in the packet capture, we also saw responses. It says no such name if you look through Wireshark or T-Shark. So yeah, this helped us figure out what was happening. But also the logging helped. So yeah, this was pretty cool. But because this was interesting, because in their environment, the way that they had set up the DNS, it was actually not detecting the NX domain attack vector. So there was a problem. So we had to adjust the rate limiting for A query vectors, and then also do an I rule to only allow preferred geolocations.
Now, that's per endpoint rate limiting as well, correct? Like you can do per client, so that each requester is limited, if I'm not mistaken. Is that?
Yeah, I think that's a feature you have to turn on, but I think in their case, we couldn't do it. It was like bad actor detection. It's based on source. But yeah, I didn't actually look into that because we were so much focused in, okay, let's stop this before the services are hugely impacted, because it was down for about, I don't know, 1 hour or so. Then they had to switch to another data center. I'm not going to say names, but yeah.
If anyone's not familiar with this specific attack out there in the community, also water torture is awful insofar as, caching resolvers. Really, it's the process. Again, if you don't understand it or know it, is, if you're familiar with NX domain attacks, right? Well, this is taking an NX domain and then looking for subdomains within it over and over and over and over and over and over again. The idea is to really exhaust the resources of the caching resolver and eventually lead to slowness or toppling of the service itself. That one was always a tough one because service providers, especially, the last design job that I had was with a service provider as an SE for F5, and one of the things that I worked on was backbone DNS. So that was a big, it was, I know exactly what you're talking about. And the thing that's hardest for me was that they don't want to just arbitrarily pitch a lot of those DNS requests. They monetize the data. So to them, each request, even if it's part of an attack, they want to understand where it came from and understand how much it cost them. And that overall leads to how they scale the platforms. It's hard in the service provider realm to actually defeat this particular attack without impacting their business and their scheduling over many, many years. That is a particularly hard one, but prevalent, right? I mean, Aaron, I imagine you've seen quite a bit of NX domain and water torture.
Yeah, we see that a lot, and at least based on the people who phone us, it goes in and out of fashion. I think that's what I find most fascinating about attacks, is that there seems to be these fashions to attack, right? So if we go back about probably a couple of years, we had a couple of quarters where basically all we saw was NX domain attacks, right? It was all DNS all the time.
Yeah.
And then it went away. And it went away, I want to say, I could figure this out if I actually went back and looked at the numbers, but it decreased during like pandemic times. It's made a massive comeback. It's just DNS everywhere all the time again.
Well, I think that speaks to what happened during the pandemic, right? I mean, because even then the hackers needed their local DNS servers and services, and so they didn't want to touch it. It's like, well, I'm going to be home, and if I need to do anything, I got to have DNS. So I think maybe it's a respect thing. I don't know.
Yeah, I wonder if, and this is entirely conjecture, but whether during the early pandemic times when we made that massive switch to everybody working from home, it was easier to maybe target individuals and work your way into businesses. There were higher value things that were more easily achievable at that point. Predominantly, there were remote workers before, but to a point where everybody was working from home and they weren't in secure locations. They weren't necessarily observing as good security as they were in the office. Okay, you can use floods like this to hide exfiltration of data and so on and so forth, but I feel like they are lower value attacks. They're more sort of retaliatory attacks. Maybe they're related to the geopolitical things that are going on in the world now. And it's easier to just, if all you care about is causing immediate financial impact, denial of service, volumetric denial of service, right? You take someone's systems down, or you flood their link, or you flood their servers, and they can't function anymore. Versus, I want to actually infiltrate a company and steal secrets, or, that kind of.
An interesting peek into the day in the life of a security support engineer. Next up, I'm going to show you what DNS water torture, or more appropriately, resource exhaustion is, with real attack stories. It's an attack that's been driving DNS administrators mad for years. DNS water torture, known more recently as DNS resource exhaustion, is really an expansion on the NX domain flood attack, whereby an attacker would send a query for a domain that does not exist to a DNS resource. This takes time for a lookup and can be very effective in a flood situation, as it really ties up an authoritative server's resources. In order to display the effectiveness of this attack, we're going to start by showing a traditional DNS flow that begins with a client asking a local DNS resource from their service provider, who then, if it doesn't have a cached response already, will ask an authoritative DNS resource for that zone. And if the authoritative DNS has a response, it will send that response back to the client. If it doesn't, it can send an NX domain, which takes up resources as the DNS authority attempts to find a response for the client's request. This NX domain response attack is typically mitigated with ease at the provider level, as the local DNS service will see an NX domain response from the authority, and typically, if the DNS administrators are good, will add the domain to a block list. Resource exhaustion makes this much worse because the attackers are using abc.domain.com, 123.domain.com, or even as simple as doremi.domain.com. The randomization ensures that the local DNS's cache and NX domain handling are ineffective. Since the authoritative resource is authoritative for the domain, it continues to process every request it receives, and eventually this leads to resource exhaustion, even on load-balanced sets of authoritative DNS servers. Eventually, they can all become flooded. To take it one step further, the provider's local DNS and caching resources also have to wait for every request from every client for every resource exhaustion attack on multiple domains to many authoritative resources. In this fashion, even a provider who is load balanced will still have their resources exhausted as well. If you are experiencing a hard time with DNS resource exhaustion, please don't hesitate to reach out to community.f5.com. The Dev Central community has got your back. And if it's really bad, of course, the F5 Security Incident Response Team responds to these requests and mitigates it all the time. Thanks for watching Real Attack Stories, DNS Resource Exhaustion. I'm Aubrey with Dev Central. Have a great F5 day. Finally, we're going to get to some of the latest happenings in the security world. Sander, Malcolm, and Aaron covering some absolutely terrifying stuff.
It's been a busy month. One of the big things that jumped out at me last month was MSI losing their UEFI signing keys, amongst other things. So they had an intrusion, and in that intrusion, they had all of their signing keys stolen for firmware, for BIOS updates, all that kind of stuff. And this is, I mean, there are lots of inflammatory headlines, right? Doomsday supply chain attack and all that kind of stuff. But it's pretty bad because this is compromise at the lowest level if someone uses those keys, right? So I think there's one thing that maybe gets glossed over a little bit in the articles is that these keys being leaked doesn't immediately make your MSI hardware, like, you aren't immediately pwned. You have to do something to get owned by this, but it does mean that an attacker can sign their own firmware update as though they were MSI, including malicious code. And if you run the firmware update, it's going to install that new firmware to whatever piece of MSI hardware you're updating, whether that's a motherboard or a graphics card, or they make all sorts of stuff, right? And the big problem that has become apparent there is that MSI don't have a way to mass revoke these keys.
Yeah.
Like these signing keys are burned into things that have long lives, and they can be updated. But that requires a firmware update, and that requires someone to like come along and take specific action. They don't have infrastructure like Dell or some of the big system integrators do to push firmware updates out to everything they've ever made. It's a big problem.
Yeah, it makes me wonder. My first thought was how many other hardware manufacturers are in the same boat, right? How many other organizations just like this, if this happened to someone else, right? Because it started with a ransomware breach. How many other manufacturers would we find ourselves in this problem with? I mean, I have no idea. I don't want to speculate and say I think it's all of them, but that's probably more than just MSI.
Oh yeah, I think we've seen reports in previous years of other hardware companies being hit by much the same thing. I think this is just the first big hardware company, right? MSI are pretty big out there, but it comes on the heels of like 3CX and SolarWinds. It's bad. There were some concerns whether the keys that were leaked could be used by 4 other like vendors' equipment other than MSI, whether it was, it was the Intel boot card keys. But though there was some concerns whether those were like, that would compromise all Intel systems, and it doesn't. They're per OEM keys. I saw some analysis from NCSC suggesting that they don't think this is likely to be exploited, and they consider the risk of abuse to be small. That was the words that they used. But that it wasn't inconceivable that these keys would be used in targeted attacks.
I was trying to think about how one would go about weaponizing this or using this offensively, and that was what I came to the conclusion of. It seems unlikely, although not perhaps out of the realm of possibility, that this could be used in any of the sort of patterns of sort of drive-by malware kind of things, where it's instead of having a pop-up that says your Windows antivirus is out of date, click here to update it. It says firmware is out of date. I mean, it wouldn't even have to say that, but something like that to download and get you to install Trojan firmware. But it strikes me that probably the more likely scenario is I am a high-end attacker, and I find through my recon that once I've actually penetrated an organization that I'm targeting, that they have MSI hardware there, then that gives me the opportunity to perhaps achieve a level of very, very hidden persistence that could be extremely useful, right? And as long as I can get my hands on those signing keys, then that's great. Now, the other part of this, of course, is the people who stole these, as far as I've been able to tell at least, they haven't made them for sale. Publicly, at least, yeah. So, or at least that I've been able to determine. So my mind immediately goes to what sort of defenses you might have against this, and what proactive actions can enterprises take to address this. And I imagine, and Aaron, you probably could speak to this more, that MSI has hopefully put out firmware updates that update the keys.
So I'm going to be honest, I haven't looked in a week or so, but last I looked, they were pretty tight-lipped on the whole topic. And the statement on their website is unupdated from I just looked April. So they all they've really said is only download firmware updates from our website, which I mean is good general advice. I agree that the barrier to entry to actually exploiting this is fairly high, because it's a malicious firmware update, right? That's not something you throw together. That's not like a piece of Windows malware that is commodity at this point. So that barrier is pretty high, but the barrier, I think, to getting people to install the stuff is probably quite low.
Pretty low, yeah.
Right? We've seen the targeted ad campaigns. You search for whatever, Windows Defender, and the first link is a sponsored link that goes to somewhere that is not Windows Defender. That's pretty easy, but
yeah. Apparently this is a growing trend of just, I mean, they're not even really exploiting anything except for SEO, but often malicious sites that are spoofing legit sites have better SEO than the good sites, which is how they end up in the top couple. So yeah, I think the vector's there. I mean, another kind of angle of this that I was thinking about is that the group that compromised them, that's a ransomware cybercrime group, right? And I feel like the firmware keys the firmware signing keys have the most value. I mean, sure, that could be sort of in their wheelhouse, but I feel like that's kind of a different attacker profile and a different set of objectives. And so my first thought was exactly what Malcolm, you said a couple minutes ago, which is, I wonder who they're going to sell it to. Mm-hmm. And I wonder if they're going to sell it to multiple groups or if they're going to sell it to one group for a lot of money. My first thought was that there's got to be some really interesting conversations happening in closed channels right now about what are they going to do with this thing. I wonder if they were surprised when they got that out of their exfiltration. Don't know.
Actually, that's an interesting question. How did we actually learn that the keys were part of what had been exfiltrated by this group?
There's a researcher, this guy, Alex Matrosov from Binarly. He was going through screenshots of the dumps. Or actually, I'm not sure if he was going through screenshots or just sort of looking at it on the dark web, but he was the one who identified the private keys. And I have to assume he saw like the key for, or like not the actual contents of the key, but some kind of thing. Because if the contents of the key were just up on the dark web as part of the screenshots, then this whole conversation is kind of moot, and then they're just out there, right? But I assume if that was the case, we would have heard that. So all we know is this guy Matrosov kind of identified something in the drop and said, "Oh, those are the keys." Yeah, big mess.
That's interesting. I mean, it's speculation. It's rank speculation, but I wonder what the odds are that the particular ransomware group we're talking about here would have realized what they had. I actually don't know how detailed those groups are when it comes to actually sorting through the massive amount of data that they exfil from a given victim, or whether they just say, "Hey, we have all your stuff," and find some juicy bits, the easiest juicy bits to find to enhance their extortion model, right? Or whether they really do troll through it and find really actionable items, right? That might have higher value. Yeah. Because if it's more the former, then in some ways we have an interesting complexion. What's the right word? An interesting situation of an interesting confluence of actions where it was actually a researcher who pointed this out, right? And if that was something that the ransomware gang had not been aware of, the cat's out of the bag now. And I'm not saying that the researcher did anything wrong per se, but I think it's interesting to see the interrelationships between cybercrime groups and the research about cybercrime groups and the material on the dark web and all of these things to generate eventually a given situation that industry has to handle.
Mm-hmm. Yeah, I would like to think that if the researcher would find it, then some other malicious actor would also have recognized that. Even but no, I take your point. It's like it would be pretty funny if they just didn't know what they had.
Which is, I mean, that's entirely possible. I mean, how much data do you exfiltrate from a company? It could be terabytes or more of data that you've taken from someone. How do you go through all of that?
Yeah, it was a little more than a year ago. We published a report where we noted that, and this was looking at a bunch of data breaches from 2021, and we noted that ransomware was the most kind of commonly observed attack vector associated with data breaches specifically. But in terms of attack activities, kind of going one level down, what we found was that we saw the growth of this trend of organizations exfiltrating data for ransom and not even really bothering to encrypt anything. And so we said, like, sure, there's some, I think it was like something like 42% of the breaches we looked at encrypted stuff, but even more than that, so like 56% were exfiltrating data. And then just 2 months ago at RSA, I went to a talk and they were talking about the single biggest kind of evolution in threat in threat behaviors. And they said the exact same thing, is that we've seen this kind of like big shift towards exfiltration as the main goal. And then kind of then they figure out what they're going to do with the data later. So this is, I mean, it's consistent with that. It's just steal everything you possibly can. Apparently it doesn't. People aren't monitoring outbound traffic that much, no, that's not fair. It's really, really hard to find. But yeah, so I also can't help but just sort of see this as part of a trend.
One last thought on this MSI leak. Malcolm, you said about if you infiltrated an enterprise and you're like, oh, they've got MSI gear, maybe this gives me a way of being persistent and invisibly persistent if you're in the bootloader. I get the impression that most of what MSI produce, and I could be off here, is aimed at the like gaming and home user community, right? And maybe their stuff is OEM'd into more manufacturers than I think, but I'm guessing that most enterprises settle on a big system integrator like Dell or HP or Apple or whoever, right? But so the risk is going to be, as we saw in some breaches recently, where someone is essentially using their own device at home and has that compromised, and that is then that device has credentials that also get an attacker access to a corporate network. And it's not to say that the persistence wouldn't be super useful in that situation, right? But
yeah, although there's probably easier ways to do it.
Yeah.
And that is an interesting point. I mean, I think a very long time ago, literally like decades ago, there was a fair amount of conversation about third-party devices, and as remote access was increasingly a model. Because prior to that, the threat model for laptops, basically, even in corporate ones, was, well, you left it in your car got broken into, you had the spreadsheet of like the corporate financials or whatever on there. And that's bad. But at the same time, it was, people were only just starting to kind of think, well, if we're letting people access stuff from their home machines via VPN or something like that, then how do we handle the possibility of bridging into our network from a compromised device, right? And full tunnel and split tunnel proxying and all these other issues. I haven't heard of a breach that was accomplished that way for a very long time.
Mm-hmm.
And I don't know whether that's just because I haven't seen it and it actually happens, and it just doesn't get mentioned, or whether or not it's just an unlikely scenario. One might speculate that in order to be able to do that in any kind of targeted fashion, you would need to do a fair amount of recon to identify users who have certain positions in a company, and then target them explicitly and find out where they live and what their IP address is and all these sorts of things. But so it may just simply raise the bar a little higher than most attackers need to get over it in order to accomplish their goals. But that's an interesting question, and I would be very, very curious to hear from anybody who say within the last 5 years has dealt with an intrusion that actually came off of a consumer device that was VPN'd into a corporate environment, right?
The one I was thinking of actually was, I don't think it was ever clear whether it was someone's own device or not, was LastPass, right? Where they got in via a Plex vulnerability. But I don't think anybody ever said whether Plex was installed on the developer's corporate machine or a home machine that happened to have corporate credentials on. It was, a couple of months ago we talked about that.
Although I suppose if you expand it out to bring your own devices, like mobile devices, phones, things like that, then we probably have seen more of that, right?
I would say that iPads might kind of be the sweet spot, right? It's like bigger, doesn't fit in your pocket, not quite as portable as the phone, more compute power, but it's also kind of has all the hardening challenges that a mobile device has compared with something that is like a Windows machine on a domain and all that. BYOD
always kind of scared me from an administrative perspective.
I'd have to say the same. On the other hand, to really do it right, and I don't know if it, well, quote unquote right, I don't know. Do you drop a hardware VPN at everybody's house and provide them with a thin client that can only connect and has no external drives and has no USB ports, and I've seen setups like that in my career in very highly secured environments, but I don't think it's particularly common because it's incredibly expensive and difficult to administer and so on and so forth. So there's always a balance between security versus cost, ease of use, ease of administration, and also user demand, right? Because I probably have 9 devices within 3 feet of me, but I know I'm somewhat of an outlier. I would probably, if I was normal, want to just be able to use my one computer to do everything.
I sort of feel like the BYOD was like a problem that the security industry was furiously trying to work out solutions to, and in the meantime, everybody just brought their devices. And
yeah,
I sort of feel like it was like the the security equivalent of popular usage and language, and all the linguists are sitting around talking about what is the right way to deal with this, and then in the meantime the language is just over here doing its own thing. I sort of feel like BYOD, that train has sailed, I think.
It's funny. I do actually know a couple of folks who work for. I'm going to call them modern orgs. So from that you can infer small, like agile. We want to be on the bleeding edge of everything. That kind of fintech space as developers, and they essentially use thin clients that remote desktop into their development environment. But in a lovely twist of irony, their thin clients are MacBook Pros. So we're going to give you a $3,000 laptop, which you will use to remote desktop into the secure environment you develop in.
Good thing it has all that M1 silicon on board, right?
And I will say, to be fair, that when I was looking at these sorts of setups, this was well before the era of any kind of virtualization or even really much sandboxing. So there are definitely ways you could configure a MacBook or any other device to be a highly isolated environment when it came to RDPing into your network. And clearly that would be the way to go. Moving on, we had a couple other topics we wanted to talk about at least a little bit. Aaron, I'm going to turn to you again to do this. The Apache Superset story.
Yeah. So, the next two things that stood out to me last month, Apache Superset was the first one. The story here is basically open source application shipped with default credentials built in. Something that the people who developed the open source application assumed everybody deploying the app would change, and everybody deploying the app did not change them. It just came back to one of those failings that we keep making in InfoSec, right? Which is, if there is a thing that should be changed every time you install something, don't work until that thing is changed, right? Whatever it is should be non-functional until someone has gone and changed that thing. Because if it's the keys to the castle, if I can just install it and it starts up and it runs, I'm probably never coming back to that thing, right? No matter how well-meaning I am as a developer or an admin, and I make a little note in my notebook that post-deployment, come back and change the secret key. We all know that by the time you've got to that point, there's 98 other line items above that thing on your to-do list, and you just never get to that one.
Mm-hmm.
Yeah, it really is a tale as old as time. I mean, just the sheer number of times that we've seen people's accounts get hit after. It's gotten better with some of the ways people are enforcing password complexity and so forth. But I remember very clearly back in the day that quite frequently you would forget your password. You'd call up your tech support. They would say, "Okay, I've changed your password to change me 123." Oh, great, I'm in. And then X number of days, months, weeks later, oh, my account got compromised. Well, why was that? Well, because change me 123 is on every possible brute force list out there. And indeed, every single time we've got any kind of device or any kind of software package that has a default cred of any kind. I mean, there are lists on the internet. It's easy to do. They always become a target. So we should be doing this better.
Right?
Yeah.
You want to brute force into Linux machines? Try root.
Yeah, exactly.
Yeah, Pi. Is it Pi with a password of Raspberry or username Raspberry with a password of Pi? I forget what it is for a Raspberry Pi, but like you can watch botnets try and brute force boxes, and when it hits the box, just look at all the passwords it tries, right? And you know exactly what kind of systems are typically exposed. This Apache Superset, I think it made news because it's from the Apache Foundation, right? But let's be clear, this isn't Apache, the web server. That would be bad because that's on hundreds of thousands or millions of systems. There's only actually 3,000 and change Superset instances out there, but the stats I saw was that there's 3,000 and change Superset systems out there, and 2,000 and change are using the default credentials. So that's quite a high percentage.
That is a fascinating data point because I don't know if anybody. I mean, I think everybody would probably say, well, of course, some people don't change the default password, right? I don't know what your off the cuff guess would be. 50%, maybe, but it probably wouldn't be 66.
Yeah.
Plus, right? Yeah.
Yeah, it's way more than I would have thought.
Yeah.
Like maybe I was just overly optimistic.
And then just to kind of wrap things up here, do we want to talk a little bit about the use of memory safe languages and their adoption?
Yeah. So, I mean, this is a huge topic, but let's just slot it in at the end, shall we? There was news towards the end of April that Microsoft is adopting Rust in the Windows kernel. And they had a quote. Let me look it up. Yeah. So at Blue Hat 2023 in Tel Aviv, the quote was from the director of OS security for Windows that you would have Rust booting in the Windows kernel or Windows booting with Rust in the kernel in the next several weeks or months. Which, I mean, we're not saying how much Rust. It could be like 5 lines, but it'll be there and he'll be right. But it's an interesting move. Like, I'm old, and therefore predominantly my experience is C and C that are not memory safe and close-ish to bare metal. Although, I know, Malcolm, you and I have looked at like compiler optimizations, and you realize just how far away C can actually be from assembly language. I mean, they have so many ways to blow off a foot. So the adoption of Rust or any other memory safe language is interesting. When I see memory safe language, I think slow. And I think that's because, like, I come back to what were runtime compiled languages and interpreted languages. And Rust isn't that. But that's, I don't know. Yeah, I see memory safe and I think, ooh, it's going to get slower.
Well, and that is exactly, I think, a critical piece for those who maybe aren't so deeply steeped in all of this stuff. I'm of a similar generation to you, and I had the same reaction. And certainly there have been languages available that handle memory in a significantly better way than C does for a very long time, but they have been primarily scripted, interpreted, bytecode compiled with garbage collection and all of these other things which add overhead. And so if you look at even a language like Perl, which is probably not even anything close to current anymore, it handled memory allocations for you. And that was great. But it came at the expense of Perl being appropriate for some projects and not for others because of performance characteristics, right? So if you needed really, really high performance, you would, of course, turn to C or possibly even optimized assembly, depending on your use case. The development of languages like Rust, where you get the performance that is equivalent to compiled C code, but also have the memory protections, is a big, big deal. It's a huge game changer. So I'm not surprised to see kernel developers wanting to look at this. And in fact, Linux has also been on a path to incorporate Rust into the kernel as well. So we're definitely going to see more of this. I'm I admit, waiting for the other shoe to drop. I don't know what that will be, but that may just be me being old and out of date and not up on the latest hotness. But at the same time, I'm excited to see where this goes. If this can eliminate even one general class of kernel vulnerability, that's a win.
It's easily the biggest class of kernel vulnerabilities. Like, if we get into other kinds of web applications and so on, then memory safe is less of a problem. But in software, in like operating systems, in products running routers, switches, all that kind of stuff, memory oopsies will be the biggest cause of RCEs. And I was just Googling as we talked. I don't know if anybody else here follows Dave Plummer on YouTube, ex-Microsoft engineer of forever, one of the sort of grandfathers of Microsoft development, who worked on MS-DOS and Windows 3 onwards. And he has a whole YouTube video series on software drag racing. What's the fastest language?
Oh,
so he's got this whole like architecture built out so that there's a standard test, which is based on prime number calculation. And you see how many passes a second you get. And the same test should be written using the same algorithm where possible in like every conceivable language. And I was just looking at this is just some dude's results, right? Who's taken Dave's test suite and run it on his machine. And number 2 for speed is Rust. C is 7th, which that's not what I expected. Zig is the fastest, and I've never heard of that.
I was going to say, I've never even heard of this.
I heard about Zig for the first time last week.
That's always how that goes, right?
Yeah.
So Malcolm, you and I were talking the other day about this general trend in security of whatever practice we all stand up and recommend, and we say, this is the good way to do it. This is the secure way to do it. In this case, we were talking about multi-factor authentication, right? Nobody should ever be surprised when the thing that the industry agrees is the best way to do things 5 years later, when that gets compromised one way or another, we shouldn't be surprised because we just told attackers what they can focus on, right? We just gave them an invitation to be like, here, wail on this thing. And I mean, like if there's a technical exploit, they'll find it. If they have to work through people, they'll do that, or supply chain compromise or whatever. So compared with you guys, I don't know that much about, well, certainly not about this kind of programming, right? Like I've never written anything in C, but I just can't help but think like, I think that Rust is great. I'm really excited about it. It's cool to sort of see this consensus. But I also can't help but look 5 years down the line and try to figure out like what is the way that this is going to come back and bite us. There's got to be something. I don't know what it is yet, but there will be some point in 5 years where we're all going to be like, oh, I wish we hadn't gone to Rust. But in the meantime, let's all enjoy this honeymoon period.
Maybe it won't be like, let's say Windows wholesale moves to Rust and all of the memory issues, the buffer overflows and underruns and overreads and all of that kind of stuff goes away. Then you're right. Attackers will just pivot. And they'll pivot to, well, we don't have to break the application code. We have to break the compiler optimizations.
Yeah, right.
Right?
Exactly.
Because the compiler is going to make assumptions. There's no way around that. Compilers all make assumptions. Again, like Malcolm, you and I talked about, I don't know, a couple of months back. Probably 6 months back at this point. And so Rust has got to be doing the same thing.
Yeah.
And it just hasn't had enough time to bake and for someone to poke holes in it yet. But they will. This isn't going to be the panacea to end all vulnerabilities.
And it's not like attackers are going to say, they're not going to retire and find new careers. They're not going to say, okay, security's over now, guys. Like everybody become a window washer or whatever. So yeah, it'll be really, really interesting. I mean, Aaron, to your point, you were saying you don't know how many lines, but I'm reading here that the DWrite core, the DWrite engine in Windows now has more lines of Rust. It has 152,000 lines of Rust and 96,000 lines of C++. So it's moving as far as Microsoft is concerned. And Mark Rusinovich, the CTO, he said that new projects should start in Rust. So like they're really actually more committed to this. I hope nobody at Microsoft finds it unfair if I say that. This seems very, very early and proactive from Microsoft. I think that's very cool.
Yeah. No, I agree.
Just kind of riffing on both what you were saying or what both of you were saying. I don't really like military metaphors that much with InfoSec. I think they're somewhat overused, but it does. What you were saying reminds me of the old adage about how generals often want to fight the last war, not the one that they're currently fighting. And in the sense that like every big change that we make or every big change in the military context that you make that solves one problem that you've had for a long time, not only solves the problem, but it changes the entire dynamic of how that activity is done, right? So 200 years ago, I'm sure that there were generals who were really, really concerned about how to keep your horses fed and watered.
Yep.
And mechanized tanks and mechanized infantry, well, now we don't use horses anymore. But the presence of tanks and mechanized infantry brought a whole nother raft of problems up.
Yeah.
How do you keep them fueled? What kind of terrain can they go over? Parts availability, all of these other things, right? So I have to think that for anything, whether we're talking about a massive adoption of Rust to address memory safety issues, maybe memory safety stops being a bug that we have to concern ourselves with because it's just simply not on the table.
Mm-hmm.
That would be fantastic. But I have to say that my joy will be short-lived because I know that by doing so, it will change the environment that we're doing computing in and something else will arise to take its
something
place,
else.
right?
Absolutely. Yeah. I mean, it's funny you say that actually, because I was reading about the war in Ukraine and they're talking about all these different tanks, and somebody was pointing out that some of the tanks that, well, the tanks that the US uses, the M1 and many other countries license it. When they designed that in the 70s and 80s, they put turbine engines in it instead of piston engines, right? So it has, I think, the equivalent of like 2 big helicopter engines in it. And it has all these advantages. It's amazing. It has, but that means that you have to have aircraft style maintenance crews instead of like the kind of guy who can whale on a diesel engine with a wrench. Now you have like a totally different class of maintenance. So, I mean, just to like add a little detail, it's exactly like you said. You design a really amazing tank and now you have a whole raft of turbine maintenance problems to deal with, right? So yeah, there's going to be another shoe here, and it'll be fascinating to kind of see how this unfolds.
Thanks for watching This Month in Security for May of 2023. I'm Aubrey with Dev Central. If you liked it, then click like and subscribe. And if you listen to it on podcast, don't forget to leave a review. We'd love to see you next month. Till then, have a great F5 day.